So good morning to everyone. Let us begin the session. As you are aware, we have already started unit number 2. Let us try to understand where we are right now. As per the module number 2, we already covered what is set theory, all the operations related to sets, various types of sets, and specific, I can say, version of set that is called relation that we also completed with respect to various types of relation like reflexive, non-reflexive, symmetric, antisymmetric, asymmetric, transitive, and we also seen how to represent relations in terms of set, in terms of property, in terms of graph. Also, we have seen what is the closure of the relation. Also, we have seen what is Warshall algorithm for finding out the transitive closure of the relation. Then at the end, we have seen what is equivalence relation. It is a relation which is satisfying the reflexive, symmetric, and transitive property. And once we get the equivalence relation, from that we are able to get the equivalence classes. So this is what uh, we have already completed discussion in the previous session. Okay, so in the previous session, we already discussed what is uh, partition, and we also seen that uh, if we want to find out the equivalence class, how to find out that also we have seen. We already seen what is the definition of the quotient set of S by R. This is exactly all the equivalence classes. What is this equivalence class one? Basically, it is collection of all the elements. Let me just check whether I have written one. Yeah. Basically, it is a collection of all the elements B. Suppose if I say equivalence class A, it means we are having all the elements B such that uh, A is related to B. Okay. And we also identified that equivalence classes are either equal or they are disjoint. There are several properties that we discussed in the last session. So, what is the conclusion now? We have already finished now this entire unit, that is 2.2. Now we need to go ahead for the next topic, that is functions. Basically, it is also every function is a relation. Please try to understand every function is a relation, but every relation is not a function. So exactly what is the difference that we will try to understand now. Yeah. So uh, let us say this is one set, this is another set, and this function is nothing but it is a relation. There is some association from this set to this set. So when we say a relation is a function, there has to be, I will just read out this clearly. Let A and B be two sets like this, and a function from A to B is denoted something like this. This is what already we have seen. In terms of R, we say A related to B, something like that. A is having function F to set A is having function F to set B. So it is an assignment of exactly one element of B to each element of A. That is, we write f of A that is equal to B to denote the assignment of B to an element of A by the function f. Okay? If it is not clear, let me just give some examples so that you are aware what is this we are talking about. Okay. So let us say we do have set A that is equal to, let us say, 1 comma 2 comma 3 comma 4 comma 5, some random some element like A, comma, B, comma, G, comma, T, comma, E, comma, F, something like that. And we say there is a function F1 from set A to set B. There can be various functions from one set to another set. So what is set A? I'm just writing here for your visual representation. This is your set, and this is your set B, that is okay. Okay. Now, what is F1? F1 is a function. It is a relation basically. What is relation are? It is a collection of ordered pairs where it is a collection of ordered pair A comma B such that small a belongs to domain and small b belongs to codomain. So your domain is this set A, codomain is set B. Okay. Now what is F1? Let us say, okay, F1 is equal to. Now coming back to this, let me just start the formal definition. So for function f from set A to set B is an assignment of exactly one element of B. Yeah. So what I'm talking right now here, it is a function f from set A to set B, which is an assignment of exactly one element of B to each element of. So we write f of A that is equal to B. If B is an unique element of B assigned by the function f to the element A of A. If a function f is a function from set A to B, we write f is a function from A to B. This is the way we denote the function. F, the name of the function is f. It is from domain to codomain. This arrow indicates it is function from which set to which set, that is domain to codomain. Okay. Prior to this, let me come back to this. So what exactly meaning of function? We are having this domain. We are having this codomain. What is the meaning that every element of domain, I'm again repeating, condition number one, every element of domain must have associated image in codomain. Now what is meaning of image? Image is nothing but if one is related to A, let us say, for example, just for your understanding, example, if I say 1 comma A belongs to F. So in this, we say A is image of 1. Or in other way, I will write this. Image of 1 is what? A. Or if I go to this codomain, I will write here pre-image of A is equal to 1. So just kindly note technical term, that is image and pre-image. A domain is having image in codomain, and pre-image of codomain is nothing but the domain. That's it. Okay. So what exactly we are talking when the function, when we say f is a function from set A to set B, condition number 1, every element of domain must have associated, there is one important one, unique. What is the meaning of unique? One and only one associated image in codomain. Every element must have associated, I will just wrap it. Yeah. So yes. So point number 1, every element of domain must have a unique associated image in codomain. When I say unique, it means one and only one. You cannot, when you say you are having one is related to A, you cannot have some another element is also related from 1. This is not possible in function. You can have this in relation, that is one element may have more than one associated element in codomain. This is possible in relation, but not possible in function. Every element of domain must have a unique one and only one associated image in codomain. This is condition number 1. Condition number 2 is not there at all. That means we are talking about only this condition, that every element of domain must have unique associated image in codomain. So is it clear or not? Please let me know first of all. Kindly respond in the chat box. Is this particular point is clear or not? When this every element of domain must have, I'm talking about f1 is a function from A to B. When we will call this f1 is a function, when every element of domain is having associated image, one and only one in codomain, that time we say if f1 is a relation, basically it becomes function. So please let me know quickly in the chat box, is it clear or not? I'm waiting to hear from you in the chat box. Kindly respond quickly. Yeah. So if there are no more questions, I'm throwing some F1 in front of you, and quickly tell me whether this is function or not. So let us say uh, 1 comma b, 1 comma d, 2 comma a, 2 comma b, 3 comma c, 4 comma a, 5 comma f. So let me know whether this is function f1 is a function or not. Yes or no in the chat box. Is this f1 is a function or not? Please respond quickly. I am waiting for your answer in chat box. Only two students are responding. What about rest of the students? Okay. Uh, Sharvari, can you unmute? Sharvari
Yes,
Gaikwad, unmute yourself. You tell me now why this is not a function.
because it should have only one. It should have a unique associative image in the domain.
Yeah, so give me counter example why it is not a function.
Um,
When I say counter example, you need to give one instance which
2A and
gives,
4A, then 1B and
pardon?
2B.
No, give me only one instance which proves that it is not a function.
Um, 2A and 4A, both have the images as on A.
You are saying you are giving answer that 2 is related to A as well as 4 is related to
And
A.
and
Because
uh
of that, it's not
and wait, 2A and 2B. Sorry, sir.
okay.
2 has two images, so it is not.
Yes, very good. You can move now. Very good. So let me go ahead now. I will give some another example. Yeah. So Nayodip, can you unmute yourself? Nayodip, Deep. Yes, Nayodip, unmute yourself. If there is no response, I am going to remove from the meeting straight away.
Yes, sir.
Next student, Janvi, unmute yourself.
Yes, sir.
Yeah, tell me here, is it a function? Yes or no?
Yes, because every element in the domain is having a unique image.
You are saying yes.
Yeah.
Okay. You can mute yourself now. Any other student? What is your opinion? Mansi, unmute.
Yes, sir.
Yeah, tell me, is it a function? Yes or no?
So I, hello, hello.
Can you please be louder?
So I think so. It
Yes.
is. It is a
If
function.
it is yes, then why?
So because every function, every domain has its codomain.
Read out this loudly. Yeah,
What,
read
sir?
loudly. These points, read out
Every
loudly.
element of domain must have unique associate image in codomain.
So what is meaning of every element of domain?
Oh, sorry, sir. No, it's not a function because there is no
Hmm.
codomain for 2. So it's not a function.
It is not codomain. We are saying element 2 from domain is not having any associated image in codomain.
Yes, sir.
Okay? Yeah, you can mute now. So this is what the basic, what is meaning of function. So please try to understand each function. This is a function, yes. This is not a function. Each function is a relation. Why? Because it is a collection of all the ordered pairs where the first element is belonging to domain, the second element is belonging to codomain. But every relation cannot be a function. Every function can be a relation, but every relation cannot be a function. That's it. So on the basis of this, we'll proceed ahead to discuss further. Yes. Now let us try to understand what are the various types of functions that we can have. This is one of the type or property you can say when we say a function is injective function. A function is said f is said to be one to one or inject. Okay, what I will do, I will go with this. Let me just go with this. If there is a function f from set A to set B, we say set A is a domain, set B is a codomain of this function f. Now f of A that is equal to B. Here B is the image of A and A is the pre-image of B. This is what we have discussed just now. And there is one more thing, that is range. What is the range of the function? The range of function f from set A to set B is the set of all the images of elements of A. I will repeat again. The range of function is itself is a set. Okay, what is that? It is collection of all the images of domain. So can anybody tell me now what is the range of f2? What will be the content of this range of f2? Range is what it is all the images of elements of domain. So can anybody tell me now range of f2 will be what? Oh, f2 is a function, first of all, yes or no? I need some volunteer, kindly, anyone student, please unmute and tell me. Yeah, Hussein, can you unmute? Hussein,
Yes, sir.
is it a function? f2 is a function, yes or no?
Yes, sir.
Yes. How?
Sorry, no, sir. No, sir. So
You are attending
who is
class
not
just
having
for a
element of
attendance or you are
codomain.
learning? You don't take it blindly, whatever I'm writing here. So, let me just add one more element, 2 comma a, okay. Is it a function?
Yes.
Yeah, Hussein, I'm waiting for you. Is it a function?
Yes, sir.
Yeah, please tell me quickly. Is it a function, yes or no? Remaining students, kindly respond in the chat box. What is your answer? Hussein, I am waiting for you. If Hussein is not responding, I will simply remove out. Where is Hussein?
Yes, sir. It's a function. Network issues.
Then why you are taking so much time? You should promptly say no, yes or no, whatever. If you are having any doubt, you should ask me. Don't ask me
Okay,
to
sir.
repeatedly ask you, Hussein, what is your answer? Hussein, what is your answer? Shall I wait for 10 minutes for this only?
No, no, sir.
This is a online session where it is, I expect it should be bi-directional. Whenever I am asking, you should immediately answer.
Yes, sir.
We should not waste our time on this. So, Hussein, you need to tell me, this is a function, yes or no?
Yes, sir.
Now tell me, what is the range of F2?
5.
Hmm?
5, no?
What 5? Read out this loudly. What is this?
The range of F
Yeah,
of
read out loudly.
the range of F A belongs to B is a set of all images of elements of
A
A.
belongs to B. Is it A belongs to B? Is it A belongs to B? Is it a belong symbol?
Sorry, A relation
This is from A to B.
A to
Function F is from the A to B. This is the way you should pronounce. Go ahead.
function A to B is
What
the
is this? Is it
set of all images of elements
all the
of A.
images of? So, is it clear or not for you, first of all? What is range? If it is clear, answer this now. What is the range of F2? Range is set of all the images of elements of A. What is meaning of the set of all the images? Where the images are present? Hussein, I am asking to you.
Domain.
Images are
Codomain.
present in domain or codomain? Hmm? Where?
Codomain.
So tell me the answer. What should I write here?
A A C B F. Sorry, A B C F.
Okay, you can mute now.
Okay, sir.
So we say that function f maps A to B. Now let us look at the function P to C with some example. P is this and some C is this, where Uh, uh, every element is some. These are some snapshots. Some element is having image. Max is having image. This is something like that. So the range of f. Suppose this is the function. Means there are only four elements, no? So the range of f is nothing but the collection of images. Now, on the basis of this, I am asking a question. The question is this: what is the cardinality of range of given function f? This is equal to what? This is what I am asking. Cardinality of range of given function f, this is equal to what? So you can post your answer in the chat box. Is it always equal to, I am asking this question now, is it always equal to cardinality of domain? Yes or no? Range of function is equal to cardinality of domain? Yes or no? Kindly respond in the chat box. Cardinality of range of any given function f, is it always equal to cardinality of domain? Yes or no? Waiting to hear from all of you in the chat box. Hope my screen is visible. So what is the answer? Kindly respond, everyone. I am asking a question. Is range of any function f is equal to, sorry, cardinality of range of any function f is equal to cardinality of domain? Now domain is nothing but this. This is your domain here in this case, set A. What happened? Why there is no answer? Swati, can you unmute?
Yes, sir.
Yeah, tell me, what is the answer?
Sir, the cardinality of range will be equal to the cardinality of domain.
So I am asking a precise question. Is it always holding true that cardinality of range of f is always equal to cardinality of domain? Yes or
Yes,
no?
sir.
Post your answer in the chat box. Shall I invite you to why you are not writing this in chat box? I'm waiting for all the answers of all the students in the chat box. Those who are not answering, I am going to remove immediately from this meeting room. So up till now, only Farina, Vira, Swati, Ruchika, Gaurav, Rohini, Arya, Sharbari answered. Rest of the students are not answering. That means I should remove them. I think by looking to these responses into the chat box, I can feel that you are simply doing copy-paste operation blindly. Some other students are saying yes, therefore you are also saying yes. None of the student has mentioned no, only except Viraj. Now Viraj already mentioned somewhere yes. Again he is saying no. So Viraj, you should
तो
just
सेल्फ रियलाइजेशन
hmm?
बाद में समझा वो अलग दिखा।
क्या है आपने नो क्यों बोला अभी बताइए विराज।
सर वो रेंज में 4 ही है लेकिन डोमेन में 5 एलिमेंट्स है ना, लेकिन वो फंक्शन ट्रू नहीं होगा।
सो इज इट यस और नो ऑलवेज?
नो लगता है।
नो लगता है क्यों दिख रहा है तो लगता है क्या है ही ना।
थोड़ा कंफ्यूजन है।
What is- क्या कंफ्यूजन है बताइए।
रेंज ऑफ F2 मतलब जो हम हमें वो दिए 4 एलिमेंट्स, उसका
दिए नहीं।
कार्डिनल 4 है।
What are those elements in the codomain who are having pre-images in the domain? So these are the elements. Okay. तो
बस
कितने एलिमेंट्स हैं? 4।
4।
ओके और क्या कंफ्यूजन है अभी आपको बताइए।
और डोमेन में 5 एलिमेंट्स, और ऐसा भी हो सकता है ना 1 का भी ए और 2 का भी ए हो,
यस
तो वो
यस
5 और
पॉसिबल।
5 भी हो सकता है ना।
So to come to this question, is it always holding true? Cardinality of
डिपेंड्स।
range of I am asking precise question. Is it
इफ
always holding true? Yes or no?
So it can also be possible that there are some elements who have who don't have a pre-image in the domain.
Yeah, yeah, it is possible. You can see your element D and element E is not having any pre-image. But our concern is here. My question is what? Cardinality of range of F is always equal to cardinality of domain. Yes or no? In general, this question I asked. Without this example, in general, I am asking this question. Is it always equal to? Is it always holding true? Yes or no?
No, sir.
No, sir.
No. Sir. Then what is the relationship between these two? If it is not equal, then what? I want to establish the relationship between these two values, range of cardinality of range of F and cardinality of domain. So what is that? Whether it is equal or you are saying not always equal. No? So what should I write here? That holds true in general. Is it always greater than domain? Yes or no? Is it always greater than domain? Yeah, Viraj, tell me quickly. Is it greater than domain always?
तो अभी भी वो छोटा ही है ना डोमेन से, डोमेन तो 5 है।
That's what I am asking.
लेस
Is
देन
it
डोमेन,
always greater?
लेस देन और इक्वल टू डोमेन।
Greater than or equal to?
लेस देन
Less than or equal to? Okay.
नहीं चलेगा।
Anay is saying नहीं चलेगा ऐसा नहीं. See, don't answer like चलेगा नहीं चलेगा. You need to think and answer. There may be if you are thinking in the right direction and if sometimes if you are having some errors, no, I will correct you. Doesn't matter. But ऐसे ही ठोक के नहीं आंसर देने का है. चलेगा कि नहीं चलेगा. You think and apply. So yes, this is right. That you should always this is always less than or equal to. This is always less than or equal to. That's it. Now, on the basis of this less than or equal to inequality, now Viraj, you can mute. We are discussing further. Hmm. Yeah. So, what are the various types of function? Number one, a function f is a to b is said to be 1 to 1 or alternatively injective if and only if it holds a property that for all x comma y belongs to a, f of x is equal to f of y implies, see, for all x comma y, you take any two x and y element from set A. If you do have f of x equal to f of y, it indicates x and y both are same. X and y both are same. I will again repeat. For all x comma y, you take any x comma y belongs to set A, that is domain. You take any two elements from domain. And if you are having f of x that is equal to f of y, that means what? Image of x in codomain, image of y in codomain. If that images are same, it implies that x and y both are same. In other words, f is 1 to 1 if and only if it does not map two distinct elements of A onto the same element of B. Okay? So coming back here, what does it mean? That now we need to answer, is it a 1 to 1? Yes or no? 1 to 1 is also called as injective. Now, when we say
No,
a
sir.
function, no, it is no, then why no? What is the counter example? Answer is right, it is no.
Because
Then counter example.
2 and 4 have the same image.
Yeah, element 2 and element 4 belongs to domain. F of 2 is equal to f of 4. This is the way you should answer. F of 2 is equal to f of 4. That is equal to what? F of 2 is what? F of 2 is what? What is this? A. But 2 is not equal to 4. Therefore, it is not 1 to 1. This is the way you should answer. Coming back. So I hope the understanding of 1 to 1 is clear. Going ahead.
Can you repeat?
Okay, I will repeat again. If you say you are having x belongs to domain A, y belongs to domain A, okay, and you do have codomain B. So if you say you are having f of x that is equal to f of y, that means what? The image of x is something like that is, let us say, x dash, and image of y is, let us say, y dash in codomain. Okay, that is what x dash and y dash. Even if your f of x is equal to f of y, if you do have something like here, f of 2, f of 2 is a, f of 4 is also a. To have one-to-one function, to have a one-to-one function, f is one-to-one if and only if it does not map two distinct elements. This is the key word. Two distinct elements of domain into the same element of codomain. If you are having distinct mapping, means x is mapped to x dash and y is mapped to y dash. If you are having x is mapped to, let us say, 1 and y is also mapped to 1, this x and y belongs to domain. In a only function, this is allowed. A element is related to only one element. A element of domain is related to only one element. This is allowed in function, but we are restricting that function in a stricter manner, that every element of a domain must have a unique, now I will repeat this way. Every element of domain must have a unique pre-image, sorry, unique image in codomain and in vice versa now. Every see here, these are the images, okay? Every image of this function must have a unique pre-image in domain. If it satisfies this way, then we say it is a one-to-one function. At present, 1 comma b, 2 comma a, 3 comma c, 4 comma a, 5 comma f, this is a function. But this is not one-to-one function because there are two distinct elements, element 2 and element 4 belonging to domain. They are mapped to the same element. This is not allowed in one-to-one. Yeah,
So what if
yeah.
every element of A is mapped to only one element of B?
That is also a function, but that is not one-to-one function. As you are saying, for example, 1 is related to P, 2 is related to B, 3 is related to B, 4 is related to B, 5 is related to B. Yes, this is a function. Why? Because every element of domain must have a unique associated image in codomain. This is satisfied. But this is not one-to-one because two distinct elements are mapped to same element. It is a function, but it is not one-to-one. Are you getting?
So but here every element is mapped to one.
Every element is,
Like every
can
element
you,
of B is mapped to only one element of B.
you don't talk with respect to B and this. You say this is domain and this is codomain, and you talk with respect to that. Then only I will
Okay, so
understand.
like
Tell me.
every element of domain is mapped with
Huh?
only one element of codomain.
Yeah. So, what is the definition for a function? Every element of domain must have unique. That is what is meaning of unique? One and only one associated image in codomain. If you say one related to B, two related to B, three related to B, four related to B, five related to B, also one related to A. So one is mapped to A as well as one is mapped to B, not possible in function. This is a relation, but not a function. Are you getting? What is
Yes, sir.
meaning of unit? One, this element 1 should be associated with only one element from the codomain, not more than one element. That is the meaning of this unique. It is not mean by that this element is should be linked only by one element here. No. Every element of domain must have unique, that is one and only one associated image in codomain. So 1 comma b, 2 comma b, 3 comma b, 4 comma b, 5 comma b, yes, this is a function. But this is not one-to-one function because two distinct elements are related to. Clear now? Any doubt regarding this?
No, sir.
No. Okay. So let us
Yes, sir.
try to understand now some other property. When function is one-to-one, in a nutshell, when two distinct elements of domain do not match to common image in the codomain, then we say it is one-to-one. Going ahead, mm, I'm just skipping this. Where is the next definition? Yeah. A function f is said to be onto or surjective if and only if for every element B belongs to B, that is every element B belongs to codomain, there is an element A belongs to A with f of A that is equal to B. In other words, f is onto if and only if its range is its entire codomain. What does it mean? Oh. At this time, in this function f2, only element A is taking part, only element C is taking part, only element sorry, A is taking part, B is taking part, C is taking part, F is taking part, D and E do not have any associated pre-image. So the participation of the elements belonging to codomain is not fully, partially, means partly elements are having pre-images. When all the elements of codomain are having pre-images in the domain, then we say the function is onto function, or also it is called as surjective function. I will again repeat. When all the elements of codomain are having pre-images in the domain, then we say the function is onto, or it is also called as surjective function. So coming to this, is it the function f2 is a onto function? Yes or no? Is the function f2 is onto? Yes or no? Is it clear or not? Whether onto function is clear or not? F is onto if and only if its range is its entire codomain. What does it mean? Is range is entire codomain means what? All the elements belonging to codomain are having pre-images in the domain. Then we say the function is onto function. So Sanket, can you unmute? I'm waiting for you. Sanket, Dagade.
Yes, sir.
Tell me whether this function f2 is onto function or not.
Yes, sir. Onto function.
Why it is onto, tell me.
Because
Yes.
uh,
That means you have not
sorry,
understood,
sir.
Sanket. Hmm?
Clearly understood now.
So who will ask? I have any AK-47 with me right now online. If you answer wrong, then I will shoot you. Sumit, can you unmute?
Yes, sir.
You need to help Sanket to understand when the function is onto function. So you need to make him understand when we will say a function is onto function. So you explain now for Sumit to Sanket when a function is called onto function. Yes,
Sir, a
Sumit,
function
continue.
is onto function.
Hmm.
Sir, a function is an onto function if every element of the codomain is present in the range. Range is equal to codomain.
Every element of codomain is
Present in range.
present in range, yes. Or alternatively, what way another way?
Range is equal to
Every
codomain.
element belonging to codomain are having three images
Three
in
images.
domain.
Yes, sir.
So Sanket, is it still clear or not? Please clarify. We are waiting for you,
Yes,
Sanket. Without
clear,
that,
sir.
we will not.
Clear.
Okay, Sumit, you can mute. Sanket, you remain unmute. And Sanket, you need to tell me now whether function f2 is onto function or not. This
Yes, sir.
given
Onto
f2,
function.
it is onto or not?
Onto function.
I think there is some problem. Let me understand what is exactly difficulty that you are facing. I will repeat from my level best. Since it is 12, I need to wrap up quickly. If element A is having any pre-image, you look at this function f2. Is element A belonging to codomain is having any pre-image? Yes or no? So, Sanket, I am asking you.
Yes, sir.
What is the pre-image element A?
No.
Hmm? What is the pre-image of A in domain? Look at this function f2.
2 and 4.
What is the pre-image of B?
B1,
What is the pre-image of C?
3.
What is the pre-image of D?
D का नहीं. F के 5.
What is the pre-image of E?
No.
What is the pre-image of A? F.
5.
All the elements of codomain, do they have a pre-image?
No.
Yes or no?
No.
Be louder.
No, sir.
No. Why no?
D और E की प्री इमेज नहीं है.
That's why this is not onto function. This is the conclusion.
Yes.
Now is it clear or not?
Yes, clear, sir.
Yeah, very good. So we'll stop here. We'll continue in the next session. Please post your attendance in the chat box.